Hi everyone and welcome. I'm Esther Madeira, social media at Olive Garden and a big fan of OpenTelemetry. Excited to be your moderator today for this live session, OpenTelemetry for Programmers. Joining us is Juraci Paixão Crolling, software engineer here at Olive Garden and one of the folks who actually helps build OpenTelemetry. So yeah, we've got the right person in the room. We know hotel can feel like a lot. Specs, SD cards, collectors, thematic conventions. But today's is all about making it practical. What developers need to know to start using OpenTelemetry in real code without getting confused. We cover the good stuff, the pain points, and share tips to help you to get started or to go deeper. Drop your questions in the chat and don't forget to follow the channel and check out our pages. Let's dive in.
Thank you, Esther. Thank you for introducing me. Hello, everyone. My name is Juraci Paixão Crolling. I'm a software engineer, and I'm here today to show you all about OpenTelemetry for programmers. So if you are a programmer, you are on the right place. I'm going to skip all of the theoretical basis for observability, monitoring, telemetry, OpenTelemetry. We're going to skip all of that and go straight into what matters for you as a developer, as a software engineer. All right, so this is our very first stream. So for the folks who follow me in Portuguese on my channels, you know how this goes. But if you are new to those sessions, as we are here at Olive Garden, the idea here is for the next half an hour, we're going to talk to you about OpenTelemetry. We're going to talk to you about observability, telemetry in general, monitoring. Today we're focusing on OpenTelemetry for programmers, but this is only the first one. We hope to get periodic live streams here in the channel, both on LinkedIn and on YouTube, so that you can learn better about OpenTelemetry. We are not here to sell you anything at all, right? So this is not about Olive Garden. We are not going to sell you anything, really. Our idea here is really to share our knowledge around OpenTelemetry on a topic that is key to Olive Garden. So the topic for us is efficient telemetry pipelines, and we believe that efficient pipelines, they start with efficient instrumentation. So that's why we're also giving a lot of attention, not some attention, but a lot of attention into the instrumentation side of the story. That's why we started the Instrumentation Score project a few weeks ago, in partnership with other companies in the observability area. So again, we're not here to sell you anything. This is going to be recorded. This is not gated in any way. You don't have to sign up for anything. You don't have to give up your email addresses to watch this one here. If you miss this one, you can just go to YouTube. It's going to be recorded there, right? So don't worry. But I prefer if you follow us online. So if you're watching the recorded session right now, join us for the next one. Why? Because I want to hear from you live. So this is a low pressure live stream, right? So give your comments, leave your comments there. I see already Matt and Kaline there on the chat. So you can leave your questions, you can leave your feedback, you can, let's make this one here a little bit interactive, all right? Okay, so let's get started. Esther, I want to share a little bit about I want to share my screen, if we can switch to that one. I think I need to write this perhaps. Yes, cool. Okay. All right, hopefully you can still hear me. And I'm going to start a slideshow. So I'm going to go deep into the code in a few seconds. But right now, I'm just going to give you a very quick introduction to OpenTelemetry. All right. So I introduced myself, but I'm Juraci Paixão Crolling. I'm a software engineer here at Olive Garden. I'm also part of the OpenTelemetry governance committee. I'm a CNCF ambassador. I help organize the hotel night here in Berlin. And I was a maintainer on the Hotel Collector or Jaeger and other projects. And as a side project on my free time, I also create content for Dosage Telemetria and a project that we just launched as well called Telemetry Drops. So this is a channel and an offering that we have for people to learn about OpenTelemetry. All right, so for the next half an hour or so, we're going to focus on a very simple service, right? So we're going to start with a very simple service and piece by piece add instrumentation to that service. So first we add the OpenTelemetry SDK, and then we add some traces and metrics. We talk a little bit about the collector pipeline, even though the session here is for developers. We do talk a little bit about the collector pipeline, because most people, when they think about OpenTelemetry, or not most people, but a lot of people, when they think about OpenTelemetry, they think about the collector. So we're just going to place the collector in the discussion here just to show you what it's about. And then we talk a little bit about the best practices. And if we have time, we have a Q&A session at the end. All right, so what is then OpenTelemetry? OpenTelemetry so if you open OpenTelemetry.io on that website, we have this definition here. Like this definition is very well thought out. Every word has a purpose here. It's a little bit outdated, so we have to change one thing or two, but it is still very accurate. And the statement says, OpenTelemetry is a collection of API, SDKs, and tools. Use it to instrument, generate, collect, and export telemetry data, such as metrics, logs, and traces, to help you analyze your software's performance and behavior. So what is important here is both what is in the statement and what is not in the statement. So things that are not in the statement are, for instance, we are not a visualization tool, right? So we don't care about how things are visual. I mean, of course, we do care that things are visualized in a way that makes sense, but we don't provide a tool for visualizing the data or the database. We don't provide a storage for OpenTelemetry data. We also, of course, we care about security and auditing, but we really focus on the software performance and behavior, right? So take this statement both for the things that it contains and for the things that it does not contain, all right? A mental model. So we have a similar image on OpenTelemetry.io, but this is a one mental model of OpenTelemetry as a whole. So OpenTelemetry, as the previous slide mentioned, is a collection of tools, APIs, and SDKs. Tools would be like the collector here, and APIs and SDKs are on the left-hand side at the top. So we have the OpenTelemetry auto instrumentation libraries. We have the OpenTelemetry API and SDK. They can send data to a third-party service like your observability providers, or they can send data to an OpenTelemetry collector somewhere. And then from that collector, data can go into different databases and different stores. It can go to different vendors for different purposes, not necessarily or not only observability. And it can also receive data from things that are not instrumented with OpenTelemetry, like your Kubernetes infra that is instrumented with Prometheus, for instance. The collector can get this data, right? So it can either scrape or it can receive data from other infra pieces that you may have. All right, so let's, with a very short introduction to OpenTelemetry, let's plant our seeds. I mean, and of course, this is Oli Garden, so we are gonna give you a lot of words resembling seeds and planting and cultivating and things like that. So this is how we have some fun here at Oli Garden. All right, so let me show you the code that I have here right now. All right, so I hope that you can all see my screen, my code editor. And we have here very, very simple Go program. So we have here a class or a struct that defines what are the fields in a specific payload. So we're calling that a payment. We have an in-memory database here for the payments, just a slice of payments, of object payments. And the main function. The main function has only 3 lines. 2 of them are basically printing things. But then we are handling payments, and we are starting the HTTP server, right? So basically 2 lines of code. The only telemetry that we have would be like this line here, like format.println server starting on port blah blah blah. Our handler, once it receives data, it determines what is the HTTP method that is being used, and then it calls specific functions based on the HTTP method. This is how we handle get payments. We just get the payments slice or the payments array, depending on the language that you come from. And we encode in JSON, and we return to the client by writing to the writer, right? So we have a response writer, and then we write to the response the JSON the JSON view of the payments that we have. And when we are handling create payments, what we do is we decode the body, and then we write the response if it is bad, or we just add things to our array and we say we created a payment. So this is all that our program is doing. Very simple, on purpose, and not observable at all, right? So this service is not observable. So what it means is, if I do a go run, oh, there's something running already on port 8080. Let me kill my bun server that is running on another terminal. All right, there you go. Cool. So I have now something running on port 8080. That's our payment service. And I just proved you that it is actually running because we had an error before. Cool. If I do a curl on that one, so curl, let me see if I can find so curl localhost payments. Okay. I have null, so I have an empty. I don't have anything here in the payments right now. But what I can do is let me do a post on this payment here. And if I get again, then I see a list of payments, right? So I did a curl posting to my API, and the data was amount 104, the currency is euros, and then I do a curl and I have my services there. All right, so my service is running, so I can test it manually. I know it's running. What I don't know though is how many requests did I run so far, and how many currencies in like how many payments in euros did I receive, and how long did every call that was made has taken to our end user, right? So we don't know, we don't have any information about our services. So if it fails, we cannot give answers about it. We cannot ask questions and get answers in return. All right, so we do have here our service is running, so let's kill it. And because I'm not crazy to do a live coding, what I'm doing here, I have some branches that I prepared. And a word of caution, like this repository was prepared for a presentation that I've given a few weeks ago at Cloudland here in Germany. So in some places of this repository, you can find references to that. This repository is open source. It is open. I believe it is already part of the Oligarden organization. So you can go to github.com/oligarden/otel-for-programmers, just like you see here on the screen, right? So github.com/oligarden, OTel for programmers, and you have access to this code. Now I have some branches, so git checkout. I think it is 01 sprouts. So this is the first iteration of our service. Now this one here is now adding OpenTelemetry SDK. What it does is we just added a few dependencies there, and in our main.go, what we are doing now is we are setting up the telemetry. We're going to go in details about what is this one here doing. And once we initialize our telemetry, we have access to a tracer. So I have a new package here called telemetry. I like having a package called telemetry for my applications. This gives me a feeling that telemetry is a first-class citizen of my applications, and it should be. Right? So without telemetry, I cannot reason about my application at runtime. I cannot reason about my application in production. I cannot tell whether my application is actually running or actually working or not. Right, so I think telemetry is very important. So I leave it at a package on its own, and then I have functions there like the tracer, which is not really necessary in this case. I'm going to show you a little bit in a little bit details later why I use this. But then I just say start. What I like to do myself is I have two mental models. I have one is I want to instrument the bootstrap of my application. And the other mental model is I want to instrument every single transaction for my application. And those different mental models, they have different purposes, and I take different decisions based on them. So while on the bootstrapping of my application, I don't care about how many spans I have, how many span events, or how many, or the high cardinality of whatever. I don't care. I just care about having a lot of information within my bootstrap trace. The idea is whenever my application starts, I generate one trace that represents the bootstrapping of my application. By definition, it runs only once for the whole application lifecycle. So I can be very verbose there. Now, for each single transaction that I have from my users, I have to be very careful, right? So I am very picky about what I instrument, right? So which spans I add, which events I add, about cardinality, and so on and so forth. Now, let's go back here to the code. So this one here is a run a span, or this is the very beginning of our trace, and it represents the bootstrapping of our application. From my telemetry package, I also get a logger, so I can log like I'm starting my service. And then for my HTTP handler, what I can do as well is, let's go there. I can create a new span for my handler, and then at the end, or when my function returns, I just then call a span.end. Right, so my span here is measuring how long this whole function is taking, from the very first line, like line 53, up to the point where it returns to the user, either in error conditions or when it's successful. Okay, cool. So this is all that I have. I think I don't have anything else in here. Yeah, that's it. All right, so let's go into our telemetry.setup function. And what we are doing here is we are passing a context which is empty right now. The version of the application, of course, the version would come from a build flag or something like that. So some external source. And then we also are passing what is the location of our OpenTelemetry configuration file. Let me make a pause here. Like, if you go into any or every single OpenTelemetry tutorial or getting started guide, or even the official documentations right now, you're going to find a very convoluted example of how to do one amount of things with OpenTelemetry, with the SDKs. And people complain, oh, setting up the SDK is so complicated. I don't like doing that. And this is why OpenTelemetry is so complicated. It can be easier, right? So there was a presentation, I think earlier this year in London, or perhaps even last year in Salt Lake City, by a few OpenTelemetry contributors. I think it was Tyler Yan and Alex Bolton, and they had a presentation about the config SIG. Now, I'm using a config file here. I'm using an external config file to configure my SDK, right? So I'm going to show you how that file looks like. In a few moments. I actually don't have the config file here. I can copy. I can generate new folders or local, and then I can copy from OD Garden. Let me copy from gaps. Hotel call local and hotel. So I actually use it myself, folks. So that's why I'm copying there. I had it for the presentation. I don't know where it went. So let's rename it here to hotel for programmers. Okay, and then I configure what is the deployment environment name and sysdev. And so this is my hotel configuration. So what it means is I can configure my application to send telemetry data to multiple places. So I can send to different OTLP endpoints. In this case, I only have one OTLP endpoint for all of the signals, so for traces, for metrics, and for logs. I'm sending everything to localhost 4318. All right, and I'm setting the service name and the deployment environment name. This way, I can have different files for different environments. I can have different configurations for different stages of my application. All right, so I can on my dev, I can send data to localhost. In production, I can send both to a in-cluster collector and some external provider at the same time. Right, so I leave this complexity. I leave that decision for runtime. I don't have to make any decisions right now during development. So this is the main advantage. All right, so let's see what the code actually does. And what it does is we call a providers from config. We're going to go into that one in a second. But then we specify a scope, and the scope here is the payment service. So this is the name of the service that we are creating. What is the version and the config file? Let's go to the providers from config. What it does is we read the file, and then we handle errors. Let's skip that part. I like doing environment variable interpolation, so I can configure my hotel.yaml with environment variables, and then here this line I interpolate that. I don't actually need it, but I like it, right? So I keep it this one here. But then the other thing that I do is I do hotelconf.parse YAML. So we're going to parse the config file, and it's going to return a struct, an object with the hotel configuration. And from that object, we generate a new SDK configuration. Right, so we call the hotel conf package. So the hotel conf package, if I hover here, you can see it's a go.opentelemetry.io/contrib/hotelconf/ then the version. And then I say new SDK, I give it the context, and I give it the config struct that we created from the config file. I like this one trick here as well. So with this here, what I'm doing is I can keep using Zap as my logging API. I like Zap. Don't judge me. I like Zap. What I'm doing here is I'm tying Zap with OpenTelemetry. Right. So what it's doing is whenever I log a statement with Zap, it ends up at my OpenTelemetry backend. Right. So this is what this line here is doing. And then I return a providers collection or object. And then we go back there. So on our code, we have providers from config. So here we have a list of providers or a set of providers. And then I set my hotel global or my hotel setup. I set it like use the provider from the config file, use the the tracer provider from the config file, the matter and the logger providers from the config file. And there is a small bug right now in hotel config, as far as I know. So I'm setting the text map propagator manually here. In the future, we're not going to need this one here. All right, this is it. So it's not very complex, right? It's only if we take the error handling out, it's mostly like this function, this helper function, plus we set the hotel globals, or we set the default providers for the things that we are going to use, and that function here, it's only like read the file and parse the file and get me an SDK. And it's and the magic for the logging ending up on our OTLP endpoint already by default. Anyway, so going back to our main file, we have the SDK, we have the OpenTelemetry set up, and now we have our data going there. So what we're going to do now is I'm going to start it. And I think we might have a backend running here somewhere. Let me see if I can find it. So localhost and 3000. Yes, it is there. Folks, I'm using Grafana, a local Grafana version here. It is a Docker image, Docker Grafana LGTM, I think it is the name of the image. Because it's easier for me, right? So I know the tool. That's what I use. You can use whatever you want. It's OpenTelemetry, so you are vendor neutral. So you see here we have a run span or a run trace we can open, and we can see that our bootstrapping took 90 microseconds or microseconds. And yeah, so we have some information here, right? So this is our very first step. All right, so let me go back to the slides and recap what we've done. So we've configured the SDK using an external configuration file. We tied our logging framework with OpenTelemetry, and we added a span telling us more. Oh, not this one. So not this one, not the last one. We haven't seen that one. We did add a span there, but we haven't done any calls. So let's run a couple of calls in there. All right, so I had 3 calls. Let me go back now to where is it? There you go, here. Let me close this, run again, and then we see for each curl call that I've made, we have 1 trace, right? So we do have now some information about each single HTTP request that we have. What we have in here is each HTTP request took less than 1 millisecond. Right, so this one took 40 microseconds, this one took 167 microseconds, and this one 23.25 microseconds. All right, so this is what we've done. Now we've done the 3 steps in here. So we added a span telling us more information about the incoming HTTP request. Cool. All right, so this is what we've done. We added a new span called payment handler. And the next step is we are going to add some metrics. All right, so making a pause here. So what is a metric? A metric is a numeric aggregation of events. So something happened, And then we have a numeric representation of either a collection of events or the current state of an event, right? So a gauge, for instance, is the current state of something, and a counter is an aggregation of like the number of requests, and the duration is a histogram, again, aggregation of all of the durations that our application is returning, and perhaps an error counter. And if you know red metrics, the request, error, duration, you can see a pattern here, right? So we have a counter, the duration, and the number of errors. All right, cool. Let me stop my Go program and let me check out 02, growing roots, and what we have in here. So folks, we are almost at the end of the half an hour. I promised at the very beginning, it's going to be very relaxed. I'm going to move forward until we are done. But if you have to drop in the next 3 minutes, that's fine. It's going to be recorded. So go to the YouTube channel and click on the subscribe button. Go to the LinkedIn page and follow the page. I think that's the terminology, right? So follow the page for updates. This video is recorded. You don't have to enter an email or anything. You can just go there and watch this video. Anyway, going back here, we have the metrics struct. And on the metrics struct, we have the red metrics, right? So we have the request, error, and duration. So number of requests, what is the duration for the request, and how many errors. And then we have some business metrics in here, like a histogram with the payment amounts, a payment by status, and payment by currency. Right. And other than that, so a metric in OpenTelemetry has, we deal with metrics in 3 stages. The first stage is we define the metric, right? So here we are defining a metric called payment amount, and this is a float 64 histogram. It's a histogram, right? The second stage is we initialize the metric. And the third one is we use the metric, right? So in our main code, in our main function, we're going to initialize the metric. So we defined here on a type struct, and then we created a var here, so a var metrics instantiating our new structs, a new metric struct, and then we initialize the metrics during the bootstrapping of our application. On init metrics, what I do is I call telemetry.meter. Oh, I forgot to tell you about that one. We're going to come back to this one here later. And then, so we are initializing the metrics. We get our meter, and then within our meter, we initialize our instruments. So we initialize the counter. We give it a name, we give it a description, we give it a unit, and then we initialize the second and the third metrics, and then the business metrics one by one, and that's it. And then we can store the initialized metrics in our metrics holder. And then when we actually use that, when we want to use the metrics, we just make reference to them, like metrics.payment amount and record. And we record what is the current amount, and we record as an attribute, we add what is the currency, right? And then perhaps payment by status, we do that. So we add a status here or a big currency and so on and so forth. What we can do as well is for each single request, we can, where is the metric here? We add the metric, we increment the metric, the request counter, we set what is the duration, and if we are in error, we can add the error counters. All right, so that's it. Let's start our program again. So go run. We can make some calls in here. I actually built a small traffic generator. So let me see if it runs. CMD traffic generator. No, it's not. Oh, yeah, it should be. Okay, cool. It's running. All right. So why? Because then we can see some metrics coming in here. Right. So let me change here to Prometheus and then we see, let's go here to the drill down metrics. We should probably be able to see payment. Yeah, there you go. So we have here payment amount currency, and eventually we're going to start seeing data there. So let's select this one. We have one data point here. So we already see that there's a payment amount currency unit count. All right, so we have it there. If I add this 5 minutes, eventually we're going to see more data points, right? So it takes a while for data to show up. What we can do in the meantime is go to the Explorer tab. Let me get payment, and let's see, payment by currency total, and that's it. right? So let's just see. So we have some data flowing in. So data is coming to our metrics, to our OpenTelemetry backend. Cool. We have some data there. What I want to show you as well is we have logs, right? So all of the logs that we have in our application, they're coming to our logging log storage as well. All right, cool. So we added some metrics. So we've defined the metrics, we initialized the metrics, and then we use the metrics, right? So again, declared, initialized, and used not only the business metrics, but also operational metrics in our code. Now, what is then the collector? Let's talk a little bit about the collector. We have a collector configuration here on the stage. Let me stop in here, let me stop here, and we get checkout 3 collector. I have a config for the collector. And what is a collector? A collector is a piece of software that runs between your application and a backend. And what it can do is it can change data in flight, right? So what we are doing here as an example, of course, the collector can do a lot more, but this is one of the things that the collector can do. Collector can also go and pick data or scrape Prometheus metrics or get logs from your local machines and so on and so forth. But the main purpose, at least for me, for the collector is to receive OpenTelemetry data, do something with that data, and send data out to our backends. This is what we are doing here. So we are defining a receiver, and one of the receivers that we have at our disposal is the OTLP receiver. It has in different flavors. We are using the HTTP flavor or the HTTP protocol. So we are starting a localhost on port 4318, and we have processors. And so receivers, processors, exporters, receivers receive data, processors process data, and exporters export data. That's it. It's so easy. So what we are doing here is for all of the traces that we are seeing, we are adding a new resource attribute called pipeline.name, and then it's called a local collector. And we send data to the exporter, and the exporter is on port 5318. So let me stop my OGLJTM. Let me docker stop OGLJTM, and I'm going to start on port 5318 again. It's taking longer than expected. Okay, cool. 5318. So this is the one that we're running. So it's the Grafana/hotel-LGTM, Grafana/hotel-LGTM image. And I'm overriding the port like 5318 for the container port 4318. Cool. So I started. What I'm going to do now is I'm going to start this collector. Now, what this collector is going to do is it's going to listen on 4318. It's going to do some processing on that data and then send data to 5318. We define the pipelines in a service node, and we can have multiple pipelines. We have here one for each data type. So one receiver, one processor, one exporter, and the same for metrics, the same for logs. But that's it. And then for the traces, we set the transform processor, which is doing this, right? So let's start a collector, contrib, config collector. There you go. Let's start our application. So go run. Collector, go run. There you go. And then in here, we start the traffic generator. Cool. All right. So if everything is working, data is coming to our collector, and from our collector, it goes to our backend. And to prove that it's working, if we see the pipeline.name in our telemetry data under the resource attributes, then we see that it is all working fine. So let's go back to our backend, click on Explore, Traces, and search, and we have a lot of data for the past 5 minutes. Cool. So it is from this minute. It is 3:36 here in Berlin. And if we expand here, we see pipeline.name local collector. All right. So we see that our collector did change some data for us. So this was the next step. So where the collector comes into the picture, into the big picture. So we created an OpenTelemetry collector configuration file with receivers, processors, exporters. There are a few other components. You don't have to know them all. As a programmer, it's sufficient for you to know what is the collector? The collector is then this piece of software that runs between your workload and your backend. We configured a pipeline that adds a resource attribute to all of the spans that is flowing through the collector, and we configured the collector to send data to our backend. Let me make a pause and see if we have questions there. Cool. All right. So I don't see any questions. So let's move forward. Now, okay. So we now have a couple of other things to mention. One is you've probably noticed that we have a few things that OTel could handle that for us. Like the red metrics, they're so common that we don't have to do that ourselves. And some of the things that we use, they could have better names, right? So if we look at our instrumentation, if we look at these here, we see that this is all payment handler, but which ones are gets, which ones are posts, which ones are puts and deletes, we don't know, right? So this is where semantic conventions come in. So the semantic conventions, they tell you, or they tell us, what are the things that we should be using to instrument our applications. We can also do instrumentation using instrumentation libraries. And at the end, we're going to talk a little bit about the purposeful instrumentation. So let me go back to the code. Let me stop the collector. Let me stop our application and the traffic generator. I'm going to go to check out the for tending, and I'm going to show you what are the differences in here. All right. So the first thing that we are doing here is we are delegating most of the common things to OpenTelemetry itself. So there are things called instrumentation libraries for OpenTelemetry, and we are going to use one for instrumenting our HTTP requests. This one for Go, OTel HTTP, it instruments the net HTTP standard library. And what we are doing here is we're just wrapping our handlers within the OTel handlers provided by OTel HTTP. And by doing that, we can remove our operational metrics from our code. So we don't need the red metrics anymore. Those are handled by the instrumentation library. And we don't have to care about the naming again. Or we actually do in one scenario, but we're going to have a better name, right? So what we're going to do is we're going to wrap, again, we're going to wrap our server in the OTel HTTP handler. So we're going to wrap our handler within OTel's handler. We're going to give it a name, so the payment service. And then for the spans, we are going to determine what is the span name. The span name is going to be the method, space, and path, right? So this actually follows the semantic conventions. Semantic conventions says it has to be the HTTP method and then the path in a low cardinality manner, right? So what it means is we don't want a /user/user123. We want /user/brackets ID, right? So the template for the URL, not the full URL or not the full path. All right, so once we've done that, what we can do now is we can start our application again. Where is it? So the collector, and then we go run, and then we start the traffic generator. We go to our tracing storage, and now we see a change, right? So now we see that we can filter by what are the, let me refresh the screen. So we get new span names. So we can filter only the spans by get, for instance, and only for our service, only for OTel for programmers. And then we see only those ones here. All right, so we can open and we know this is a get request. And not only that, but now we have a bunch of other span attributes. So we can better understand the request. So we see it is a call to the /payment, /API/payment. This is the peer address. So this is localhost, the status code, what is the body size, and so on and so forth. So that information we didn't have before. That was added for us by the library instrumentation that we're using. All right. So and then after we talk about the instrumentation libraries, we have to talk about purposeful instrumentation. And purposeful instrumentation for me is the difference between telemetry that exists and telemetry that's useful. All right, so we have a lot of options to instrument our applications. One of them is by using instrumentation libraries, and there are tons of them, right? So if you are doing Spring, for instance, for pretty much every single line of Spring code, that is an instrumentation library. So it's very tempting to get all of them. but don't. Get only the ones that are relevant for you. Get only the ones that provide value to you. The same for the auto instrumentation libraries. We have a lot of auto instrumentation libraries out there. You can use them all. But then every single auto instrumentation library brings information that is so generic that it might not be that useful for you. So purposeful instrumentation means I know that I have an instrumentation gap here, and I can fix the gap with that instrumentation library. I can fix that gap with that auto instrumentation tool. So then you have a purpose of using it. You're being very thoughtful about the decision. All right. So this is the purpose of instrumentation. Take a look at the instrumentation score, instrumentationscore.com, scan the QR code, or just enter instrumentation-score.com. It is the project that I mentioned before, and it goes into this direction, right? So it helps you determine what are the good and the best practice, the good practices and the bad practices around instrumentation. All right, so I'm going to give you a final pro tip. This is something that I was trying the other day, so I'm playing with a lot of AI tools nowadays. One of the things that I like really here nowadays is I can just link the OpenTelemetry semantic conventions into my repository using Symlink. And I can just tell those tools, like in this example, it's Cloud Code, but it can be anything really. It works with Gemini, CLI, it works with anything really. You can just say, can you verify that our code is aligned with the semantic conventions as defined in semantic conventions? So this is a Symlink. And then it just does it for us, right? So it will take a look at our code and match with the semantic conventions. One hint is, always mention you want the latest semantic conventions, right? So I was bitten by that the other day. So just say, can you verify that our code is aligned with the latest version of the semantic conventions as defined in blah, blah, blah. And then it's going to come up with a plan for you to fix the code for you. Right, so you don't have to know all of the semantic conventions by heart. You can use that, and it does an actual good job in figuring that out. It requires humans to verify, so it is good if you skimmed through the semantic conventions before, but it's not really necessary. Now, a well-tended garden has a trace that looks like this, right? So our example had something very simple, just one span. A real-world example would be like this, right? So we have in this case, we have Nginx that is doing being the front door for our services, and then we have our rain catcher. This is our ingester service, and it ingests data. And our end user has an experience of 3.35 milliseconds, even though the whole transaction took 136, which is pretty good. Each one of those is a microservice that is doing a specific insight verification. And we can see the whole transaction. So this is one HTTP request, and we can really understand very, very nicely everything that happens here, right? So this is what a well-tended garden is. I mean, I can see one thing that is not very perfect, and that is this pen here might be high cardinality, but it's okay. It's not too high cardinality right now. So some takeaways before we wrap it up. OpenTelemetry is an observability framework, right? So it is a collection of APIs, SDKs, and tools like collector and operator and so on. But also a set of best practices and documents and standards like the semantic conventions, the OTLP protocol, and the OpenTelemetry specification itself. It was made to be interoperable, so you can pick and choose which parts of OpenTelemetry is good for you. You've seen how I picked Zap as my logging API. I like that. I can plug Zap with OpenTelemetry. The same happens can happen with the metrics API. If you don't like OpenTelemetry for metrics, that's fine, as long as as long as it gives you a solution, as long as it provides you value, you should use whatever you feel like using. I prefer using OpenTelemetry for traces and metrics for my use cases. I think having one mental model for the data model and for how things work is easier for me. But you do you, right? Again, you don't have to use OTLP if you don't like it. You can use the other protocols. You don't have to use OpenTelemetry APIs and SDKs. You can replace each single piece and apply purposeful instrumentation on your data routine. It really is part of our day jobs as developers. to understand what is our instrumentation. In most modern companies, people who write code, they run the code. And if you run your own code, you have to understand what your code is doing. And the best way of doing that is by thinking about instrumentation when you are developing your application. So you look at your application, look at your code, and during the review process, take a look and think, like, what is the information that I need during runtime, during like at 2 a.m. in the morning when I get paged? What is the information that I need to debug this problem, to really fix this problem? Now, that was pretty much it for today. Obrigado. Thank you very much for staying with us. And I'll be happy to take some questions. But if you have questions after this conversation here, that's fine. You can just connect with me on LinkedIn. The QR code is here. The link is here. Send me a message. I'll be more than happy to get in touch with you. And Esther, I think we are wrapping up, right? Oh, you were on mute.
Okay, now that's a wrap. Huge thanks to all of you who joined us for today for Open Telemetry for Programmers. We hope this session helped demystify some of the complexity and gave you a clearly picture of how Open Telemetry can support your work, even if you're not deep in code every day. If you like this chat, don't forget to follow the channel, check our pages for more content, and share your feedback. We really love hearing from you. Thanks again, and see you next time. Thank you, Juka.